Hello class, today we're going to talk about lesson 4.3, measures of central tendency. And our objectives for today are that we can find the mean, median, and mode of a set of data. Our vocabulary alert, so the mean is the sum of the values divided by the number of values. Some things you'll see in problems where you know you'll have to find the mean are if they ask what is the average or what single number best represents the data. We also have the median, which is, we have two situations with this. If we have an odd number of data, it's the exact middle number. If we have an even number of data, we need to take the average of the two middle numbers. Now, if we encounter having to find the median in a word problem, they might say, what's the halfway point of the data? We also have the mode, which is the value or values that occur most often. They might say, what is the most common value in a word problem? Alright, let's look at our first example where we need to find the mean, median, and mode of the following sets of data. Our first data set is 4, 8, 8, 3, 6, 8, 3. We're going to start by just finding the mean, which means we're going to add all the numbers together. We're going to go 4 plus 8 plus 8 plus 3 plus 6 plus 8 plus 3, and we're going to divide all of that by how many numbers there are total, and there are 1, 2, 3, 4, 5, 6, 7 numbers. So we're going to divide that all by 7. Now if we find the sum of our numerator, 4 plus 8 plus 8 plus 3 plus 6 plus 8 plus 3, that's equal to 40. So we need to go 40 divided by 7. Now 40 divided by 7, we don't know that off the top of our heads, but that is approximately 5.7. It's between 5 and 6, just a little closer to 6. Now let's find the median. Now to do that, we need to arrange the numbers in our data set from smallest to biggest. And our smallest numbers, we've got 2 3s, so we're going to write 3 down 2 times. Then we have a 4 and a 6, followed by 3 8s, our biggest numbers. Now when I'm trying to find the median, I go and I cross off one number at the lowest end, then one number at the top end. And I keep doing that until I get to the middle, which in this case is 6, so our median is 6. Our mode is the number that happens the most often. Now 3 happens 2 times, 4 and 6 both happen 1 time, but 8 happens 3 times, which makes our mode 8. Now let's look at another set of data. We've got 9, 6, 91, 5, 7, 6, 8, 8, 7, and 9. Let's start by finding the mean. So we're going to add all of those numbers up. We're going to go 9 plus 6 plus 91 plus 5 plus 7 plus 6 plus 8 plus 8 plus 7 plus 9. And then we're going to divide that by how many numbers there are total. And this time there are 10 numbers. So when we add up the numerator, we get 156. So this is equal to 156 divided by 10. And if we do that, that's exactly 15.6. So our mean is 15.6, or our average is 15.6. Now let's do the median. So we're going to write out our values. We've got 5, 6, 6, 7, 7, 8, 8, 9, 9, and 91. Now we're going to eliminate the 5 and the 91, a 6 and a 9, another 6 and another 9, a 7 and an 8, and oh, look at that, we've got 2 numbers left. So we have to find the average of those 2 numbers, which means we have to go 7 plus 8 and divide that by 2. So we're going to have to go 15 divided by 2, which is 7.5, or 7.5. So our median of this data set is 7.5. Now, which number or numbers happen the most frequently for our mode? Well, 5 only happened once, 6, 7, 8, and 9 all happened twice, and 91 only happened once. So we've got here 1, 2, 3, 4 modes. We've got 6, we've got 7, 8, and 9 all for our modes. Let's look at one more set of data. We've got 28, 12, 101, and 53. Let's find the mean of this. So we're going to go 28 plus 12 plus 101 plus 53. And divide that all by 4 because we've got 4 sets of numbers, or 4 data points. Now if we find the sum of the numerator, that is 194 divided by 4, which is approximately, or exactly, 48 and a half, or 48.5. So our mean is 48.5. Now let's look at the median. We're going to write these numbers in order from smallest to biggest. So we've got 12, 28, 53, and 101. We're going to start by crossing off the 12 and the 101, and we're going to be somewhere between 28 and 53. So we need to add 28 and 53, 28 plus 53, and divide that by 2. So 28 plus 53, that's going to give us 81. And 81 divided by 2 is exactly 40 and a half, or 40.5. Now let's look at our mode. Each of the numbers happens the exact same time, which tells me that there is actually going to be no mode in this situation. There's no statistical way to find our mode. Here's our second vocabulary alert of the day, an outlier. An outlier is just an extreme number in a set of data which is either much bigger than the rest of the data points, just like the number 91 in example 1b, or a number that is much smaller than the rest of our data. Now let's look at an astronomy application, example 2. We're going to use this table of planets and their moons to find the average number of moons for the terrestrial planets, which the terrestrial planets are Mercury, Venus, Earth, and Mars. So, we've got 0 moons on Mercury, 0 moons on Venus, 1 here on our home planet Earth, and 2 on Mars. So we're going to go 0 plus 0 plus 1 plus 2. We're going to divide that by 4 because there are 4 terrestrial planets. 0 plus 0 plus 1 plus 2 is 3. And 3 over 4 is exactly 0.75 moons. The average number of moons on the terrestrial planets is 0.75 moons. Example 2b is asking us to find the average number of moons for the gas giants, which are Jupiter, Saturn, Uranus, and Neptune. Now, Jupiter has 39 moons, Saturn has 30, Uranus has 21, and Neptune has 8. So we're going to go 39 plus 30 plus 21 plus 8, and divide that by 4. Now, if we find the sum of our numerator, that is 98. And if we divide that by 4, that's going to give us exactly 24.5 or 24.5 moons on the gas giants as an average. Now, part C wants us to find the average number of moons per planet. So for all the planets. Now, we know Pluto is no longer a planet, but this table, or this data, was given to us in the year 2002, which Pluto was a planet at that time. So, we're going to still use Pluto. We're going to have to go 0 plus 0 plus 1 plus 2 plus 39 plus 30 plus 21 plus 8 plus 1 divided by, in 2002 we had 9 planets, so we divide that by 9. Now, if we find the sum of the numerator, that's 102 divided by 9, which is approximately 11.33 moons. So if we took and evenly distributed all the moons in our solar system to all of the planets, each planet would have 11.33 moons. Now, for the rest of your homework tonight, I want you to take the Your Turn problems and complete them for class tomorrow. Have a good night.